This is a video lesson for 3.2.1, solving inequalities with one or two variables. Before we start, please take a look at the notes I have provided and make sure that you look through and see if you understand. I want you to know the difference between open, closed circle, and how to write inequality symbols based on a number line. For today's lesson, some of these problems may be a review of the previous math, or some of these may be new. The very first problem that we're going to be looking at together is a very, very important problem that introduces inequality problems for integrated 3. So please make sure to think about each of these questions first on your own, answer them on your own, and come back to continue with the video. So the first question, part A, just looking at the equations. If you were to set those two equal to each other and come up with this one giant equation, how can you solve this equation using the graphs for the left function and the right function, and what are the solutions? So part A is a review. Let's first look at the graph and identify which one of these is for y sub 1, which is what I labeled in pink. Which of the two parabola relates to the first equation? Well, the tip here is that this last constant will always tell us the y-intercept. So then which of the graph have a y-intercept of -3? It's this one, the one below. So I'm going to color that with pink because that's my y sub 1. And then the other equation will correspond to the other graph, which has a y-intercept of +3. So I'm going to also mark that with the same color, which is now orange. So then, in our previous lesson, how do we solve a one-variable equation using a graph? Well, we graph the left side function, which is now the pink parabola. We graph the right side function, which is the orange parabola. Find where they intersect, which is this point over here and this point over here. And we look at the original equation. The original equation only has the x variable, so it's going to be the x coordinate of those points of intersections. So again, this point of intersection has an x value of -3, and then this point of intersection has an x value of 2. Again, we only state the x value of those points because the original equation right now that we're trying to solve graphically has only x variable. Now part B, we already answered this question. How do you decide which graph is which equation? We looked at the y-intercept, right? Both have a value that are positive, so both of them are opening up. But then the key is the y-intercept. The pink graph has a y-intercept of a -3, which matches with the constant. And then the orange one has a y-intercept of +3, which is matched with this one. Another thing you can see is the a value of the pink graph. A value is +2, so this is stretched by a factor of 2, which is a skinnier graph, and that's also still the pink graph. So please take a look at my answers for part B and see if you understand the stretch factor and the y-intercept. So part C, now we're solving an inequality, and we want to use the graph to identify the x value, because again, the original inequality right now only has the x value, so we're only asked to identify the x values, where this graph, which is our y sub 1, the pink one, has x values that are less than or equal to. This means less than or equal to the right side equation, which is x squared plus 4x plus 3. Take a look at the graph. Find all the x values where the pink graph has values that are less than or equal to the orange graph. So here's another hint. A translation for this problem is to find x values where the graph of y sub 1 and y sub 2 intersects because of the equal sign. Find where they intersect, and there's a less than symbol, so also find where the graph of y sub 1 is below, because it's less than, graph of y sub 1 is below the graph of y sub 2. Where do they intersect? And where is y sub 1 below y sub 2? And take a look at the graph. That's going to be over here. This is where the y sub 1 and y sub 2 intersect. And then where is y sub 1, the pink graph, below the orange graph? It's right here. This is where y sub 1, the pink graph, is below y sub 2. So what are the x values? What is the domain where the y sub 1 is below y sub 2? Let's take a look. The x value where they intersect starts at -3, and they're intersecting, and that's what we want because of the equal sign. So from -3, -3 included, because that's where they cross, all the way to, because this is where y sub 1 is below y sub 2, so all the way up to the next intersection, which has an x value of +2. So find the x values. Where are the x values where they intersect and y sub 1 is below y sub 2? It's going to be between -3 to +2. So you're going to write answer as an inequality where the x values are greater than or equal to -3 and less than or equal to 2. That's going to be the solution. So please take a look and see if you agree that between x value of -3 to +2 is where they intersect, which is the equal sign, and this is below the orange graph. Part D, how can this be represented on a number line? So how can the answer for part C be represented on a number line? And you just draw a number line for the answer for this. You have graph going from -3 x value all the way to +2. And that's where y sub 2 is below, y sub 1, is below y sub 2 and equal to, and that's the graph. X is greater than or equal to -3, but less than or equal to 2. Another way to write this, you can also write it as x is greater than or equal to -3, so one at a time. This part is where x is greater than or equal to -3, and the left side, looking at the left side now, it's going to the left of 2. So, and x is less than or equal to 2. This answer and this answer are both the same. Well, there's a specific name for this, and we call this a conjunction. Whenever we have an inequality where 2 points and we got a number, we got solution where they're merging together, they're connected together, we call that a conjunction. Okay, so I left an extra note there, so please take a look. Now we're going to move on to the last part, which is E. E. We're going to do the same thing for now for a different inequality. So instead of being less than or equal to, please notice that the inequality has changed. Now we're looking at where the pink graph, the y sub 1, which I named, is greater than, just greater than, the pink parabola, which is our y sub 2. Where is y sub 1 greater than y sub 2? Pause the video, take a look at it, see if you can identify where the pink graph is greater than or above the orange graph. Okay, so coming back to the graph, as you can see, here's another number line. Now we're looking at greater than, so you can use the same idea of how I showed part C. Where is the pink graph above the orange graph? Where is it greater than? I see that from the point of intersection to the left is where the pink graph is above the orange graph. And then from the point of intersection, the other point, to the right of it is where the pink graph is above the orange graph. So let's see. If we use that point where they intersect, but this time, do we care where they intersect or not? No, there's no equal sign. We don't care. So the point of intersection is not part of my answer because we don't care where they intersect or not. There's no equal sign in the inequality. So we're going to do an open circle at -3. We're going to do an open circle at +2 because, again, we don't care where they're equal to. It's not part of my answer. I'm going to use that point, and then from x of -3 to the left is where my pink graph is above the orange graph. And then to the right of x of 2 is where my pink graph is above the orange graph. So here it is. Use a number line once again. I'm looking at where my graph is left of -3, and then I found that my graph for the pink graph, or y sub 1, is above when x is greater than 2. So this time, now you see that the inequality on a number line, it's a little bit different from what we saw. Here we had closed circle, but now we have open circle because we don't care where it's equal to. There's no equal to there, so we don't want our solution there. We want to keep it open. And this is now going opposite direction. They're not merging, they're not meeting together, it's going opposite direction. So let's write an inequality one at a time. Left side is where to the left of -3, so x is less than -3. The right side is where to the right of 2, so that's greater than 2, x is greater than 2. And since they're going in opposite directions, now we use the word or. And that is the solution, and we call this a disjunction. This is a disjunction. If they're going in separate directions, then we use the word or, and we call it a disjunction. Whereas over here, if they're meeting together, merging together, we use the word and that's going to be a conjunction. You can write an answer with an and like this, or you can write it this way. With disjunction, there's only one way to write the answer. And if you have more questions about why we have open circle at -3 and 2, please read these notes below.